Hey there, and welcome. Today, we are going to tackle one of the most powerful forces on our entire planet. And if you have a quiz coming up on plate tectonics, trust me, you are in the perfect spot. All right, let's get you ready to absolutely crush this thing. We're going to go through all the key vocab, the big ideas, everything you need to know. By the end of this, you're going to walk into that test feeling totally confident. So, first things first, before we get into the details, we have to understand the main theory, the big picture that ties everything else together. This is the foundation for pretty much everything. And here it is, the most important idea. The ground we're standing on isn't one solid piece, not at all. It's actually a giant jigsaw puzzle made of these huge pieces, these tectonic plates, and they are always moving, really, really slowly. This one idea explains mountains, earthquakes, volcanoes, the whole shebang. So what are these plates actually made of? Well, here's your first key vocab word, the lithosphere. Just think litho, like rock. This is the hard, solid, kind of brittle outer shell of the Earth. It's the plate itself. Okay, so if the plates are hard and rigid, how in the world do they move? Well, they float. They float on this layer right underneath called the asthenosphere. Now, it's not a liquid. Think of it more like super thick, hot tar. It's soft, it can flow, and that's what allows the rigid plates of the lithosphere to just kind of drift around on top. Now, listen up, because I can almost guarantee you're going to see this on your quiz. You have to know the difference. The lithosphere is the rigid plate. The asthenosphere is the soft, gooey layer that it floats on. One is solid, one flows. Got it? Awesome. So, it's a pretty wild theory, right? That the continents are moving. But how did we actually figure this out? Well, this next part is kind of like a detective story, where scientists had to piece together all these clues from millions of years ago. And the story really begins with this idea of Pangaea. This was a massive supercontinent, a time when all the land on Earth was basically smushed together into one giant piece. The entire story of plate tectonics is really the story of Pangaea breaking apart. The first clues came from a guy named Alfred Wegener. He started noticing things that just didn't make any sense. Like, how could you find fossils of the exact same ancient reptile in both South America and Africa? And why do mountain ranges on different continents seem to line up perfectly? The only way it made sense is if the continents had once been connected and then drifted apart. But the big question was how? What force could possibly move entire continents? Well, the answer was found at the bottom of the ocean. Turns out at these huge underwater mountain ranges called mid-ocean ridges, hot magma bubbles up from the mantle. It cools, hardens, and creates brand new ocean floor. And this process literally pushes the old seafloor and the continents on top of it away from the ridge. And here's the smoking gun, the ultimate proof. As that new crust forms, tiny magnetic minerals in the rock line up with Earth's magnetic field. And since that field flips every now and then, it creates this barcode-like pattern of magnetic stripes. And scientists found that the pattern on one side of the ridge was a perfect mirror image of the other side. That was it. Undeniable proof. So we know the plates are moving. What happens when they bump into each other or pull away from each other? That's where all the action is. That's what we call the plate boundaries. Okay, this slide right here, this is your most important study tool for the whole quiz. There are 3 types of boundaries, and you have to know them. But don't worry, I've got a super easy way to remember it. Convergent means collide, divergent means divide, and transform means slide. Just burn that into your brain. Collide, divide, slide. That's all you need. All right, let's zoom in on those convergent boundaries, where plates collide. Usually, one plate is heavier and denser than the other, so it gets forced to sink down into the mantle. That process is called subduction. It's a huge vocab word to know, because subduction is what creates those super deep ocean trenches and fuels the most explosive volcanoes on Earth. Now, all of this colliding and dividing and sliding, it isn't gentle. When these massive plates of rock grind against each other, they release an absolutely incredible amount of energy. And we feel that energy on the surface as earthquakes and volcanic eruptions. Here is another pair of words that students mix up on quizzes all the time. The focus, that's the actual spot inside the Earth where the rock breaks and the earthquake starts. The epicenter is the point on the map, right on the surface that's directly above the focus. So, focus is deep down, epicenter is up top. And sometimes, when a really powerful earthquake happens at a plate boundary under the ocean, it can shove a gigantic amount of water upwards. That creates a tsunami. These aren't just big waves. They are a whole series of incredibly powerful surges of water caused by that violent shift in the seafloor. Let's lock in one more super simple vocabulary pair. It's so easy. When that hot, molten rock is still underground, we call it magma. The second it breaks through and erupts onto the surface, we call it lava. That's it. Magma is inside, lava is outside. And that lava builds up to form different kinds of volcanoes. You've got your shield volcanoes, which are really wide with gentle slopes, like the ones in Hawaii. Then you have composite volcanoes. These are the classic, tall, steep, cone-shaped ones that can have really violent eruptions. And finally, you have cinder cones, which are much smaller and are basically just piles of volcanic ash. Okay, you have been doing an amazing job. We've covered a ton. So let's do a really quick rapid-fire review just to make sure the biggest ideas are stuck in your brain for that quiz. You ready? All right, think fast. We just talked about this. Where does magma get a chance to make it to the surface and form a volcano? There are three main places. And there they are. You find them at convergent boundaries where subduction is happening. You find them at divergent boundaries where plates are pulling apart. And you find them over hotspots, which are these weird areas where super hot magma just punches right through the middle of a plate, like in Hawaii. Okay, this is it, the most important question. If you can answer this, you are in fantastic shape for your quiz. What are those three magic words for the plate motions? That is it. Convergent plates collide to build mountains. Divergent plates divide to create new oceans. And transform plates slide past each other, causing earthquakes. Just remember, collide, divide, slide. You've totally got this. Now go ace that quiz.